Chapter 2, Section 4, Transformation of Functions. We're going to go ahead and go through all of these. These are parent functions. I'm going to tell you what you have to know from what you don't have to, well, not that you don't have to know, you have to know, but what you really have to focus on, okay? So let's go ahead and jump into it. Parent functions, this is absolute value. So when you are looking at the absolute value, please make sure you are understanding what kind of graph this makes. Absolute values make this kind of V graph, which is right here. Oof. Okay, just to check, what I would like to do is plug in values. You don't have to plug in specific values for this, but I'm going to show you that it works. So when you're looking at absolute value, you know you have an X and a Y. If my X is 0, what is my Y going to be if I plugged it in? What's the absolute value of 0? It's also going to be 0. If X is 1, the absolute value of 1 is 1, and all of this can be graphed on here. So here's 1, 1. If X is 2, the absolute value of 2 is still 2. And let's just say if X is 2, the absolute value is going to be 2. So if X is negative 2, it's still going to be positive 2. So it makes that V shape. So that's something that you have to know if you're looking at it like this, okay? So absolute values make the V shape. You have to know that when it's an absolute value, it makes a little V shape. All right, looking at it, we should know domain and range because we did this before we went on break. So domain stands for which values? Good, I have my X values. And my range stands for my Y values. Okay, we should know how to write domain and range. So looking at it, what is my domain here? What is my domain going to be? Looking at my domain, I'm going to have negative infinity to positive infinity. Remember, domain's my X values, so if I'm looking at it right here, that's my X values. Range is my Y values. So looking at my range, I'm going to have brackets 0 to positive infinity. Why is it going to be a bracket? Because I'm starting at 0 with the closed circle. There's nothing down here in my negative section. So it's from brackets 0 to a positive infinity. All right, going ahead and looking at the next one. I'm going to go ahead and go to quadratic function. Okay, so I have x squared. F of x equals x squared. And what does that look like? It's like a little u starting at 0, going up on left and right. Okay, so same thing. I'm going to go ahead and just show you that it works by plugging in some values. I have x and y. So if x was 0, y is also going to be 0. 0 squared is 0. If x is 1, y is also going to be 1. If x is 2, y is going to be 4. Okay, so now you can see that it has that curve. It's not a V, it's more of a U. It's going to have a curve shape. So now if x was negative 2, negative 2 squared is going to give me a positive 4. Okay, and that's going to be right up here. So it does make that little U shape. Okay, so something you have to know here, if you have x squared, it makes that U shape. And then let's go ahead and find the domain and range. So domain in this case is going to be negative infinity to a positive infinity. Remember, domain has to deal with my x values, and this goes on forever and ever and ever in both directions. And then my range is going to be bracket 0 to infinity. So looking at it, again, same thing as the last one. Okay, same thing as my absolute value. I'm starting at 0 and there's nothing valued down here. All right, looking at the next one, I'm going to go ahead and go to cubic function. Okay, so when I have a cubic function, it's x to the power of 3, and it's going to be a squiggly line going up and down. Okay, so a little curve in the center. Redraw this one because, yes, I'm starting at the origin, and it's curving up. It's going to start curving down. There should not be any little up part here. So just go ahead and take that part out. This should not be there. It just goes straight down. Okay, so looking at the same thing, I'm just going to give you some values just to see that it works. I have x and y. I'm going to have 0 for x, 0 for y. I'm going to start there on the origin. If I have a 1 for x, I'm also going to have my 1 for y right here. If I have 2 for x, that's 2 cubed, that's going to give me 8. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. It's going to be somewhere up here if I graphed it correctly. Same thing, if I have -2, it's going to be -8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Again, if I had graphs, it would be more accurate, but yes, it should look something like that. Okay, so it is a curved line going up and down. Same thing, domain and range, finding my domain. I'm going to be at -infinity to +infinity. And now my range is also going to be at -infinity to +infinity. All right, important thing for a cubic function is it's cubed, x cubed, and it's going up and down. So that's something you have to know. All right, going ahead, going to my cube root function. So cube rooting it. Graph for this is going to be going to the right and going to the left, starting at the origin. Same thing, I'm going to give you some values just so you can see that it works. I have x and y. If x is 0, y is also going to be 0. If x is 1, y is also going to be 1. Okay, now if x was 8, cube root of 8 is going to be 2. So 1, 2, 3, 4, 5, 6, 7, 8. And it's 2. If it was graphed correctly, it'll be somewhere right here. And then same thing, if I have -8, it's going to be a -2. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Okay, and again, -1, and it'll be -1 still right here. So it works. It's going to have that little curve from the left and curve to the right. And finding my domain and range, -infinity for domain to +infinity. And then range is -infinity to also +infinity. And highlighting, you have cube root and the graph. All right, going to square root. All right, square rooting is right here. If I'm square rooting something, this is what my graph is going to look like. It's just going to be a line going to the right, okay? Keep in mind it does not make a U. If I were to draw it this way, this is not a function because it does not pass that vertical line test. Okay, so if I draw my vertical line, it goes through 2 places. It cannot happen, so that is a no. So it's just this line right here when they're asking to graph something for square root. It's just that one line. And same thing, showing you using values, plugging in. If I have an x and y. If x was 0, y is also going to be 0, so that's fine. I'm starting here at the origin. If x was 1, y would also be 1, so I have 1, 1. If x was 4, the square root of 4 is 2. So 1, 2, 3, 4, 1, 2, that would go right here. Let's see, if x was -4, okay, let's say I'm square rooting -4. I'm going to get 2i, and I cannot graph 2i. So I can't have negatives for my x. So it cannot work. Okay, I cannot go in the negative direction. So same thing as before, looking for my domain. Domain, again, is your x values. It's going to start at 0. I'm starting at 0 and going all the way to infinity. And my range, same thing. I'm starting at 0 and going all the way to infinity. All right, so looking at everything, I kind of highlighted what you have to know. You have to know which graphs are associated with whichever function, okay? So please be aware of that. You're going to see in the next slides why I'm telling you this. You have to know which graphs are associated with each function. So just quickly going over it. When you're given an absolute value, it's a v. When you're given a quadratic function, it's a u. A cubic function, okay, it's going up and down. A cube root function, it's going side to side. And then your square root, it's just going one side, okay? So you have to be able to understand these, study it, memorize it, think about it. Remember, you guys are getting quizzed on 2.5, and you will be graphing. So if you don't know what the graphs are or what they look like, you have to. So please make sure you bookmark this page, star it, highlight it. Make sure you guys know these. All right, we're going to go ahead and do transformations of graphs. Transformation just means a shift. Okay, you guys should have done this last year in geometry, but we're doing some sort of shift. Vertical, horizontal, stretch, shrink, reflection. Okay, so please make sure, again, you know the last slide. Okay, vertical shifts. If you're looking at it, all you're doing for vertical shifts, or how do I know if it's a vertical shift, is you're adding something outside of what's given. What do I mean by outside? You're going to see the difference between vertical and horizontal. So vertical, it's outside. I'm adding a number. When you're adding a number, you're moving the graph up according to the number that's given. Okay, so this one is going up. Okay, so vertical is up and down. So when I'm adding, I'm going up. When I'm subtracting, I'm going down. Okay, so here's my subtraction. I'm moving the graph down according to the numbers, and addition was going up. So please make sure you understand. Adding and subtracting means either up or down the amount of numbers. So we're going to go ahead and look at some of the examples. Please pay attention to the examples. And again, you have to know the graphs according to the function. So looking at number 1, graph each function. The original graph or original function is x squared. So again, x squared is my original. This is a square root, not a square root, just kidding. This is a quadratic function. So what did my quadratic function look like? It was a u. So I'm going to start at my origin and I'm making my u. Does not have to be perfect. Just please at least make sure it goes through the origin and at least 1, 1. Okay, so I kind of want to see those points. Now I'm adding 2. When you're adding, that's vertical. Am I going up or down? Okay, make sure you guys ask yourself those questions. Am I going up or down? So I'm adding 2. It's vertical, and in this case, I'm going up. How many units? 2 units. So starting at my origin, I'm just going to kind of zoom in. I'm going up 2 units. 1, 2. That means I'm going to start my graph at 2. It's still going to have the curve. Please do not make it look like a V. It has to have some sort of curve right here. Okay, and the blue is my final answer. This right here is my final answer. This is what my new graph is going to look like for this given function. Okay, looking at the next one, same thing. What was my original function that I started out with, or they gave me looking at what's here? Okay, I'm square rooting. So this is a square root. What did a square root look like? I'm starting at the origin and going to the right. Okay, it's a curve to the right. So I'm subtracting 2. What is that going to look like when I'm subtracting 2? I'm now going down 2. So in this case, writing it here, I'm going down 2. So starting at the origin, 1, 2. This is where I'm going to leave off. And this is what my new function is going to look like. Okay, it's going to be that curved line right there. So looking at this, again, when it's outside, you have to pay attention if it's plus or minus, if I'm adding or subtracting. All right, looking at horizontal shifts, the difference between vertical and horizontal, I like to look at it and say, okay, with my horizontal shift, my number is going to be inside what was given. Okay, so if I was looking at a vertical shift, my vertical was f of x equals the absolute value of x plus a number. So understand the difference. This is vertical. And this one's horizontal. So you can see that now my numbers are on the inside of what's given, okay? They're on the inside of what's given. So understand the difference. It's on the inside, it's inside the parentheses, it's inside the radical, it's inside the parentheses, it's inside everything. So when you're given horizontal shifts, it's either moving left or right. So when it's adding, in this case, it's going to the left. And if it's subtracting, it's going to the right. So again, think of it as the opposite. Adding to the left, subtracting to the right. The examples, graph each function. Is this vertical or horizontal? This is going to be horizontal because it's inside of my parentheses. So the original one that we had or was given is x squared. And it's a horizontal shift, so I'm adding 2. If I'm adding 2, am I going to the left or to the right? I'm going to the left because I'm adding, I'm going to the left. So I'm going to go ahead and draw, I'm going to the left. 2 units. Okay, so starting at the original, x squared is going to be my u. Oof, let me just draw this a little better. Okay, so this is my x squared, my function x squared. And now I'm going to the left 2 units. So 1, 2. That means I'm going to go ahead and start right here. 1, 2. Okay, again, as best as you can, just a rough sketch. This is my final answer. I move to the left 2 times. Okay, if you can, start at the bottom and at least go through the 1, 1. But this is what it should look like. All right, looking at the next example, let's go ahead and look at what they're giving us. This is also x squared. And now I'm subtracting 2. So if I'm subtracting 2 and it's inside, this is also a horizontal shift, and it's going to the right, also 2 units. So starting at the original, and then going to the right 2. 1, 2, start here, and it's going up. So it should look something like this. Again, it has a curve. It is not a V. It's more of a U. So please do not make it look like a V. You guys, again, will be graphing them. So please make sure you see or show me that curve. All right, looking at the next one. Is this one also inside the parentheses? Inside anything? No. So in this case, this is not a horizontal shift. This is a vertical shift. Okay, so again, it's not inside my parentheses. This is a vertical shift. And because it's a vertical shift, and it's at -1, it's going to go down 1 unit. So again, I started with x to the power of 3, which looks something like this, starting at my origin, curving up something like this, and down. Okay, now my shift is going down 1 right here, and then I'm still gonna have a curve. So in the end, what's in blue should be my final answer. All right, I'm looking at the next example. Okay, this one, I'm gonna have 2 shifts. Okay, I'm gonna have a vertical shift right here. Okay, and because it's +1, that's telling me it's going up 1 unit. And then I'm also gonna have a horizontal shift. And because it's +2, that means I'm going to the left 2 units. My original was x to the power of 3. So starting with x to the power of 3, starting with that curve up. Oof, I don't like that. And then curve down. I'm going to go ahead and go to the left 2 units. 1, 2. Kind of put this in a little more of like a dotted line because that's not my final answer. And then I'm going to go up 1. So here and here. What's in blue would be my final answer. Okay, I shifted to the left 2 and I went up once. All right, let's go ahead and check the first one. So looking at the first one, I have a vertical and horizontal shift. So if I'm looking at this one, I mean, you could do whichever one you want first, but I do see a vertical shift, which is my +2, and a horizontal shift, which is my -3. So in this case, looking at it, I'm going to go ahead and I'm going to the right 3 units, and then I'm going up 2. Doesn't matter the order you want to go in. And I know I started with x to the power of 3. So x to the power of 3 looks something like this. Starting at the origin, it's going to curve up and then curve down. So I'm going to go to the right 3. 1, 2, 3. That's going to end up starting right here. And then I'm going to go up 2, 1, 2. And it should look something like this in the end. Do you have to get specific points? I just at least want to see that you pass through this point and this point. Okay, so again, these are the key points that I want to see. This one and this one. And this is your final answer. Curve up, curve down. Okay. Going ahead and going to number 8. Going to number 8, this was an absolute value function. And again, I have vertical and horizontal. So absolute value functions, just so we know, is going to look something like this. Okay, I have my v. So -3 and +2. Okay, so my +2 is telling me I'm going to go up 2 units. -3 is telling me I'm going to go to the right 3 units. Were they the same? Oh, they were. So I'm going to go to the right 3, 1, 2, 3, right here. And then I'm going to go up 1, 2, right here. And again, I have my V shape. And this is what it's going to look like in the end. And what's in blue is my answer. Okay, please make sure you remember which one's vertical and horizontal so you know, and the graphs.